Protocol analysis of IPv6. Is that protocol stack really doing what we think it is on the wire? We no longer have to guess. We can look with Wireshark. Let's begin. There are two types of network engineers when it comes to IPv6. There's those people who have worked with it and practiced with it and implemented it, and there's those who will be practicing and using and implementing it. It's not a question of if, it's really a question of when. So I've got a question for you. Do you suppose that every implementation of an IPv6 protocol stack, for example, Windows, Linux, HP, Palo Alto, Cisco, Juniper, etc., do you suppose they all function and implement it the same exact way? And the answer you're probably saying is no. There's going to be some slight differences, and it's important to know what those differences are. One fantastic way to help identify the actual behavior of the packets on the network is to set up a network as a test and then use Wireshark to validate what you expect is happening on that network. So here's what we get to do in the video. I'm going to walk you through setting up a very simple, easy test environment where we can start capturing the traffic. And some things we want to be aware of and take a look at are Neighbor Discovery Protocol, or NDP as his friends call them, with router solicitations, advertisements, neighbor solicitations, advertisements, and duplicate address detection. And you know what? It only takes bringing up a single computer to do all of those in the first few seconds of a device coming onto an IPv6 network. We can also verify in the Wireshark capture about the various addresses that are being used. The unspecified address, the link local address, the global address, the multicast addresses, and also the solicited node multicast group, which every computer is going to be joining that's on an IPv6 network. So let's bring in my favorite test emulation environment, and that happens to be GNS3. This is version 8.4, release candidate 3. So it's a fairly current version, and they did make a slight change in the interface, but the functionality is the same. So I've got a cloud that represents a VirtualBox host-only interface, and it's connected to a router interface gig 1/0 on R1. If you haven't already taken a look at it, there's a full GNS3 series on CBT Nuggets that goes into all the nitty-gritty detail about getting the most out of this emulated environment. For now, we're just going to use it to practice capturing traffic of IPv6 on this network link between the PC that's going to be sitting on that VirtualBox interface and the router itself. So let me move GNS3 out of the way, and let's bring in the router. This represents R1 in that GNS3 topology. If we want IPv6 on this router, we need to make sure it's enabled. So let's go into configuration mode on R1. Now, IPv6 is not configured on this device. We're going to go ahead and do it from scratch. So if you want to, you can replicate these steps and have the same results. IPv6 routing for others is not on by default on a Cisco router, so we're going to enable that with the IPv6 unicast-routing command. Now it's enabled. Next, we'll simply go into interface gigabit interface 1/0 so we can go ahead and modify the parameters for IPv6 on that interface. So now we're in interface configuration mode. It would probably be a great idea to make sure the interface is in an up state. So on a Cisco router, to do that in interface configuration mode, we're going to use the wonderful command no shutdown. That's how I taught my dog to sit, by the way. I said no stand, and it sits. It's a Cisco dog. I'm just kidding. My dog sits when I tell it to sit. If my dog wants to, it's got a mind of her own. So now interface gig 1/0 is up. Next, and this is an optional step, just because I'm doing protocol analysis, I'm going to hard code the layer 2 MAC address on this device. That way, when we see it, we'll see that anytime we have MAC address of 0000 followed by ones, we'll know right away that that's the MAC address on the gig 1/0 interface on R1. Now, before we continue with any IPv6 specific interface configuration, what I'd like to do is bring back GNS3. And let's go ahead and start a wire capture on this link between where the PC will be and the router itself. So we'll right click on this link. We'll say start capturing. We'll say OK. And that capture is now currently running. Now this next step is optional as well. We don't have to do it, but I enjoy hard coding a layer 3 IPv6 link local address on my router interfaces. That way I know exactly what they are and what they're going to be inside of a wire capture, instead of using the EUI64 where it makes up the host ID or the interface ID. So I'm going to specify an IPv6 link local address of FE80::1, and the keyword link-local at the end is what tells a Cisco router that, hey, by the way, that IP address, even though it began with FE80, which is a link local address, the keyword lets the router know that it is a link local address. If you leave that off, it doesn't recognize on its own power that it's a link local address. So now we've got a link local address, but we can't communicate off of our local network because link local addresses are link only in scope. So we also need to configure a global IPv6 address. So to do that, we'll simply specify IPv6 address. And let's see here. For an IPv6 address on this guy, let's use 2001 DB8, which is set aside for documentation purposes. And let's put them on the 5:5 subnet /64. And then we'll verify the details of this interface with a show IPv6 interface for gig 1/0. And here's the details. We've got our link local address right here. Fantastic. We've got our global address right here. We've joined this multicast group because we are speaking IPv6 on the network. We've joined this multicast group because we are an IPv6 router. And we've joined this multicast group, which is the solicited node multicast group. And that's based off of the last 24 bits of the link local address and global address. If these two had different last 24 bits, this device would have joined two different solicited node multicast groups, one for each of the IPv6 addresses that it has configured. That looks great. So let's go ahead and stop our capture. I'm going to go back to GNS3, right click on this and say, please stop capturing. And then I can minimize that. Next, what we're going to do is work on the Windows 8 client who's sitting on that network along with the router. Its interface is currently shut down. So I'm going to go ahead and start a brand new capture. And with that capture running, let's go ahead and bring up this interface. So we'll enable it. And also, I just want to make sure just at the moment that it's currently set up for IPv6 because that would also be important. So IPv6 is enabled, IP version 4 is not. And then we can go ahead and click on OK. And let's take a look and verify the details. From the command prompt, we can do ipconfig. So we've got a default gateway, which is the link local address of our router. That's FE80::1 right there. We also have our own link local address, and we also have a couple of IPv6 global addresses. I mean, holy schnikers, isn't one enough? Well, with privacy extensions, no, one isn't enough. So it has a second one that rotates periodically, which could help avoid predictability by somebody analyzing all the traffic that's coming off of a given network. So let me stop that capture as well. And now we have two capture files, one where the router booted up and one where this Windows 8 client booted up. And just for grins, let's do one more test. I started a brand new capture, a third one. Let's do a ping to FE80::1. That's our default gateway, and that should work as well. So now we've got three separate captures. I'm going to stop that capture right now. So here are the files that are in the Nugget Lab files waiting for you. I've got the router starting up, the Windows 8 starting up, and then also the ping. I also have the basic router config that takes a router from 0 to hero as far as IPv6 is concerned if you wanted to emulate that same scenario that we did in this video. These are all available in the Nugget Lab files. So let's take a look at each one of these. Let's start at the router starting up. We can just double click on that. It'll automatically bring up Wireshark. Let me bring that into position. And I happen to be using the profile VoIP from our previous video, so if you're still using those settings, it'll be just like this one. So these packets, FF02::16, that multicast group is for multicast listener report messages. I'm going to go ahead and take those, and I'm going to get rid of them. I'm going to say anytime there's a destination with that address, I want to create a display filter so I don't have to look at it. The easiest way to do that would be go to that as a destination address, right-click, and say prepare a filter, and not selected. That should remove it. Verify that's what you want and apply it. What you may notice is that as we've gone through this series together, your skills and your comfort level with Wireshark and the ability to use the tools is becoming more natural and more effective every time you practice it. We could also remove these loop protocols. There's only a couple of them, but if we want to get rid of those as well, just to clean up the screen, we can say, you know what? If it's protocol loop, we can simply right click and say prepare a filter. We'll say and not selected right there. So not IPv6 destination of FF02::16 and not loop. And we'll apply that. So what I find interesting, these first two packets here, these are neighbor solicitations that he's doing and is part of the duplicate address detection. So he's going to be using a link local address. It's interesting though that this router, even though we hard coded a link local address, it still did duplicate address detection looking for the EUI64 format for the interface ID, even though it's not using that. From the output of the show IPv6 interface command, we saw that it's not using this link local address, but somewhere in its brain, it actually sent out the packet to see if there was another address like that on the network. And that's one of those interesting things that you might not expect to see, but the packets aren't lying here. These are literally sent on the network. And this neighbor solicitation right here, packet number 5, if we look at the details of that, it's being sourced from the unspecified address from an IPv6 perspective. That's because it doesn't have an IPv6 address yet. And it's going out to the solicited node multicast group address regarding the IP address that it wants to go ahead and use. So if anybody currently had FE80::1 in use, they would see the packet destined to this IPv6 address. They would respond and say, oh, yep, I've got that address. You have to do something different. You can't have that one. In this case, there's no competition. No one's out on the network yet. So he takes it. In fact, right here, packet number 11, he is sourcing a packet from his link local address, doing a neighbor advertisement because he's so proud that he is now the proud owner of FE80::1. Because IPv6 unicast routing is enabled, he's also doing a router advertisement. And then when we configured a global address on the interface, it said, oh, I better do duplicate address detection to make sure that address is not in use either. So this is the solicited node multicast group that someone who has this IP address would have joined. If he'd got a response back of someone saying, yep, I've got that IP address, you can't have it, he would have had to do something else other than use it. But no one responded with a conflict, and as a result, he's so proud of that, he now sources a packet from his global address as a neighbor advertisement. Sort of like having some great new event happen. You want to tell everybody about it, and that's what he's doing right here in packet number 16. Now, the next trace we have is the Windows 8 machine booting up. And the reason I put these in separate files is I wanted to demonstrate another really cool technique that might come in handy from time to time. What if you wanted to take a couple of files and merge them into one bigger capture file? It's really easy to do. At the moment, we have opened the router starting IPv6. So what I'd like to do is take this current capture that we have and merge it along with the Windows 8 so we can see all the packets in one file. To do that, it's really, really simple. Let me go ahead and remove the display filter I currently have. Go to the very top packet just to make it nice and clean and pretty. And we'll say File and Merge. When we say merge, it's going to ask us and say, okay, great. Where's the other capture file that you want to merge with this one? So in the new pop-up, I'm going to say, I want to bring in the Windows 8 starting PCAP and click Open. Now, once that's open, check out the title. It now says, ooh, untitled. We need to save this as the final file that has the contents of both of those captures. Let's do that right now. So we could go to File and Save, or we could use the Save icon right here. Either way would be great. We'd simply navigate to the folder where we want to keep it. I'm going to call this Router and Windows IPv6. And I'm going to save that in a PCAP NG format. One of the benefits of saving in that format is that if we add comments and notes to the actual packet captures, they will stay. So if you want to do annotations and comments, PCAP NG is really the best way to save these. So we'll click on Save. And then we've got the content of the router booting up. And if we scroll down, we'll also run into the PC booting up. And I've got a question for you. Let's say we wanted to focus just on the packets that were directly involved with our Windows 8 computer. How could we set up a display filter to do that? Because we have, IPv6 addresses coming and going. How do we sort out just that Windows 8 machine? One option would be to go grab the MAC address. So I know this packet right here, this guy, packet 54, just looking at the IP address, that is our Windows 8 box. And we could do an ipconfig/all and look at the MAC address. So all we need to do is go to the layer 2 address here, which I also, by the way, hard-coded on that Windows 8 machine to make it easy to find. I had it end in 6 8s in hex. We can simply select that and say prepare a filter, say selected, and then just modify it up here. Instead of saying Ethernet source, we'll simply say Ethernet ADDR, press enter, and now all of these packets, either as a source or a destination layer 2 address, represent that Windows 8 computer. So now if we go to the very top of this, all of these are involving him. So here's his neighbor solicitation. So he wants a link local address of that. So he's doing a neighbor solicitation, which is part of the duplicate address detection, seeing if anybody else currently has this link local address. Now, unlike the router, when this Windows 8 box took it, it didn't send an advertisement. I don't see an advertisement here. What I do see here in packet 20 is I see him using that address as a source address. And now he's doing a router solicitation asking, hey, any routers on the network? And we should have a router advertisement that's coming back. Now, a router advertisement, it might be sent out to FF02::1. And as a result, our display filter is not going to pick that up because the layer 2 address of the Windows box may not be there. And what we're going to do is just highlight packet 20, take off our display filter, and there is our router advertisement right there. We also, if we knew the ICMP type, we could say, you know what, I want to sort or filter based on that. So we could right click on that and say prepare a filter, selected, and that way it would only show us router advertisements based on the ICMPv6 type. It's also interesting to me how much traffic the Windows 8 box generates just by coming up, including some DNS lookups to a deprecated IPv6 address space, but it's still part of the code, and it's still really happening on that Windows 8 box. And again, that's one of the benefits of having a protocol analyzer to take a look at what's really happening on the network when these devices come up and interoperate with IPv6. Another item that I just want to briefly mention was that in router advertisements, let's go ahead and find one again. Here's one right here. Packet 12 will do just fine. If we take a look at the flags inside this router advertisement, there's a managed address, there's the other configuration. So if we wanted to, for example, use stateless DHCP to hand out just DNS information, we'd want our router advertisement to go ahead and set a 1 there for other configuration. That would trigger a client who saw this router advertisement and learn the DNS information via DHCP stateless operations. Now, what I've discovered is that when I do this based on various clients, not every client responds appropriately or the same to that bit being on or off. For example, Windows XP is going to be different than Linux. Linux is going to be different than Windows 8. So that's one of the benefits of having a protocol analyzer to take a look at what's literally being sent on the wire and also taking a look at how various clients respond to it. And the key is we want to determine all this before we start rolling out IPv6 to a whole bunch of clients and just wondering how they're going to respond. In this video, you and I have taken a look at how simple but yet important it is to start validating the behavior of IPv6 on various devices. Using a protocol analyzer like Wireshark is a perfect way to help validate what you think is happening at the wire based on configurations you put in at the command line on various network devices running IPv6. Your homework assignment is simple. Take the trace files, the capture files that are in the Nugget Lab section, and take a look at the detailed packet by packet behavior, and that will be a great opportunity to increase your understanding and insight to what's really happening in IPv6. Now, many people say, okay, Keith, where can I get more detailed information on IPv6? I really need to master this content. Where do I learn that? One great resource is right here at CBT Nuggets. Go check out our IPv6 series. I think you will love it. I really appreciate the time that we've spent in this video. I hope this has been informative for you, and I'd like to thank you for viewing.